This is the last session between you guys and the STEMtish, so we better get going. So my name is John Arthorn. I work at IBM on cloud-based tools, mainly the Eclipse Orion project, which is a browser-based tools platform. And this is my colleague Martin Lippert, if you want to introduce yourself.
Yeah, hi, I'm Martin. I work for Pivotal, and I'm working for the group at Pivotal who's doing the Spring Tool Suite and all the, I call it all the time, XYZ integration for Eclipse for all the different projects at Pivotal, like the Cloud Foundry integration for Eclipse, the Spring integration, Gradle, Groovy, Grails, and so on. That's what my team is doing, and we're interested in looking ahead, what comes next.
Right. So today we're talking about moving developer tools into the web, into the cloud. How do we get there? So first I'm going to give you a little bit of context why we're doing this. What are the motivating factors that are pushing us in this direction? And then we're going to spend quite a lot of time on a demo where we really want to show you what we have. It's really this stuff is actually really, it's only when you see it that it really clicks how valuable this technology is. So we're going to spend a lot of time on a demo, and then we'll come back and explain how the demo worked and get a little bit into the architecture of the system, and we'll try to leave a lot of time at the end for questions. Okay, so what's our starting point is we have all these tools on the desktop, right? We've been building tools on the desktop for 10, 15 years. We've got a large range of tools. We have from simple editors to really powerful IDEs, huge ecosystem of plugins for them, and it is really it's all based on this notion that the desktop provides this one place where all my tools can come together and coexist and integrate together. So some of the key capabilities is really good for working offline, of course, and it's cross-platform, right? So IDEs, the major IDEs that are available work on Windows, Linux, and Mac. So, as of 10, 15 years ago, those were all the platforms that developers cared about running their tools on. IDEs run on all of those. But, since IDEs came about, or desktop development tools came about, the world has changed. So, this PC is exactly what computers looked like when we started developing IDEs. And everything about IDEs is built around those assumptions. So there is a single display with a very particular resolution. There's a single hard drive. There is a very fixed amount of available memory. There is a very small fixed number of CPU cores. So everything in our tools is built on these sort of grounding assumptions of what the compute platform is available for us to run on. But meanwhile, there's this new computing platform on the web, and others have basically thrown away those base assumptions of what our compute platform looks like, and made the assumption that, what if the user interface that we interact with is ubiquitous? It could be, many different kinds of devices, many different form factors. What if I had infinite compute resources available, unlimited bandwidth available? It's kind of hard to imagine in this particular conference center, but in some parts of the world there are, you're always connected, you always have, high bandwidth to other compute resources. What could I do with that kind of, if I start from those kind of assumptions, what can I build, right? And we've seen in other domains outside of tools, a lot of people have, started from those assumptions and built something quite different. And now that we see, the promise of this, we see a lot of applications in other domains that live on the web, that live in the cloud, that sort of break free of this single device, single display assumption. We've seen how powerful it is, right? The way we interact with computers has totally changed over the last even 5 years. And when we see what these other applications are doing, it makes us raise questions about our tools. How come our tools can't do some of the things that we see from native, born on the web, born on the cloud applications? So for example, when I go to google.com and I start typing a search and a drop-down appears, that is giving content assist over the entire internet. And it's instantaneous, right? That is an incredibly powerful thing, whereas if I look at my desktop tools, it takes as long or longer to search over just the local set of files I have in front of me. So that really shows, the scale of the kind of things you can do when you break free of those old assumptions. Or why is it so hard to collaborate when writing code, right? So I love Git as a source code mechanism, but it really, if I want to use that as a collaboration mechanism, there are many steps involved to get my code back and forth to share with others. Whereas we see in other applications, see how seamlessly we can collaborate on Twitter or on Google Hangouts or in other applications where they make interaction and transfer of data back and forth absolutely seamless. Like, why can't we have that kind of seamless collaboration in our tool environments? Also, if I'm building tools for Java, for example, which Java only changes every 3 or 4 years in an interesting way, my tools don't really need to move much faster than that. But if I'm building applications for a runtime environment that changes really quickly, like if I'm building applications for the web and browsers have new releases every 6 weeks, my tools have to constantly be keeping up to date. Like, what if my runtime is a cloud platform that might actually have changes every day, right? Services on the web, APIs, applications move very, very fast, and the tools have to be able to keep up with that. And with my desktop tools, there's a lot of work involved, right, to maintain my tools, to update my tools. There's a lot of friction in that experience, whereas applications in the cloud sort of do this in a very frictionless, seamless way. So, we all know this pain. If you get a new computer, or if you temporarily aren't able to use your computer, you're at home and you forgot to bring your laptop home, how painful it is to recreate your entire development environment, developer experience on a new computer, right? It's because we were rooted in these assumptions of one machine, and we built software that works well on one machine but doesn't transfer easily to other machines. So these are all kinds of, they're fundamental limitations in the architecture that we have built our tools on, or the sort of base assumptions we built our tools on. So how about the cloud? So how about moving tools to the cloud where we have these different set of assumptions? So I think I've been through a lot of these advantages. One of the other ones I didn't touch on was actually the configurability options. So if I work, for a large German manufacturer and I have very strict constraints over what tools are used to build my application, or I'm in aerospace, I want to have very tight control. In the cloud, that's a very easy thing to do, right? You can, tomorrow, a new release of Orion will come out. There's 30,000 users on Orion Hub. It'll take 5 seconds for all 30,000 users to get that new release. It's absolutely seamless, and it's instantaneous, and it allows you to control the tool environment for a large set of developers very easily. Okay, so that's, here's this platform that can do these wonderful things. What's the reality today? So today we're seeing cloud tools emerge. There's, every week or every month there is some new cloud-based editor or cloud IDE coming online. You get the real sense that it's a startup world where there's just so much activity happening. And these tools work quite well in very specific domains. So if you have, a very specific DSL or a very high-level like domain where you don't have a huge amount of tooling capability you need, these browser-based tools can do that today, but they don't have the sort of general purpose, wide-ranging capabilities that we have on the desktop. So we have this difficult choice, right? So we see these cool new tools. They can do wonderful things. They have these new properties that our desktop tools don't have, but they don't have all the capabilities we need, right? Back on the desktop, we have, as I said, this huge ecosystem of plugins. I have a huge set of existing tools that work. If I go to the web, I lose those desktop tools. So I'm faced with this really difficult choice about, do I stay behind, or do I move ahead and feel the pain of the missing pieces until it catches up? But the question that Martin and I have been asking is, what if you could have both? How could we enable both to using those desktop tools and starting to take advantage of cloud capabilities and cloud tools? And the solution, or the project where we're exploring the solution is called Flux at Eclipse. So it was created earlier this year, I think, and it's part of the new cloud top-level project that was announced this week. And really the goal of Flux is to explore this. How do we move towards the web without leaving our existing tools behind? And with that, I think we'll turn it over to Martin to show you a demo of what we've explored so far.
Okay, great. Thanks, Don. I would like to show you a demo of the stuff that we've implemented so far, and talk a little bit about how that's working behind the scenes, and what's the goal. How does it feel to build these kind of things for us, and what ideas do we have in mind for this? Since we said that we do not want to throw away the desktop IDE, we want to do both. I started with the stuff that I use today, and I use today my Eclipse IDE for Java development, mostly. In this case, is a version of Eclipse, STS, Spring stuff that we're working on. But it's basically Eclipse, but you can also imagine using another IDE that I'm not allowed to mention at this conference, maybe, I don't know. No, but you can imagine having a desktop IDE, you can do real full Java development, you have all the features that you love, right? And you continue to do that. But in addition, in this case here I have an example project, like it's a Spring MVC project, nothing really exciting here. So everything is here on my machine, but what I can do now is I can connect that to Flux, which basically means I can connect my project to the cloud. First of all, that doesn't change anything. Right? My files stay local on my machine. I can do whatever I did before in the same way. I can use my Eclipse, I can compile my stuff, I can execute stuff locally, I can do exactly the same stuff because everything stays local. But in addition to this, your files and your projects and resources are being synced to the cloud. It's a little bit like, let's say, Dropbox for code. Right? Stuff stays locally, you can work on your code locally, on your files. But in addition to that, they are being synced to the cloud, and that's done by Flux, or at least what we're exploring in the Flux project. And this gives you new options and new possibilities. For example, since this is now connected to Flux, I can open up my sample installation of Flux, which is running on Cloud Foundry in one of the data centers in the US somewhere. And I can see, among other projects, my Spring MVC project is now accessible with the browser as well. This is an Orion UI, and many of the Orion components here. So I have my project here, and I can start to work on my projects. I see here my resources and my home controller, for example. I get nice syntax highlighting for Java. That's great. And if this would be a kind of a boring small toy project, that might be enough. Right? Enough to have some kind of syntax highlighting. That's enough. I know the rest, right? I know the methods. I don't need more stuff. But if you would like to work on real Java projects, you would like to do more, right? You would like to get reconciling, good content assist, all that stuff that you're familiar with from a desktop IDE. And we are starting to allow that and to enable that inside a browser-based UI, inside a browser-based tooling. And you already see that this hello local variable is marked with a warning saying, oh, this is not used. And this looks familiar because it's exactly the same warning that the compiler produces inside Eclipse. Right? So you get the same level of information here when you change the file, when you do something with your file. And as I said, it is a little bit like Dropbox for code. I did not tell you the full truth, because the syncing mechanism in Flux is not only enabled for storing a changed file, right? You work on a file, you change it, the change is being stored and synced to the cloud. Flux is also able to sync stuff live, so while typing. And this allows a bunch of possibilities. In this case, for example, there's a service running in the cloud that knows about Java. In my case, that's my Java headless service that is running also on Cloud Foundry somewhere in a data center in the US, and that is doing additional stuff for me, like when I'm starting to type, the real life reconciling and errors, warnings, all that stuff. You see that feels already like if you would be in Eclipse and typing in your editor. Errors, warnings show up while you're typing, at quite a good speed, especially when you think about, hey, we had this conference, and the service, the Java service that's actually really producing those errors, it's sitting somewhere in the data center at an Amazon data center in the US somewhere. So the browser, in this case, doesn't know anything about Java, except from syntax highlighting. So the Orion component, the Orion editor, doesn't know anything about, oh, this is Java, and there is no Java compiler or parser being re-implemented in JavaScript running inside my browser window, because we do not like to re-implement everything all over again. We like to reuse existing bits and pieces. And JDT in Eclipse is an awesome technology for Java. So that's leveraged here, running as a headless service inside the cloud, and is also listening to those live edit syncing changes that I'm doing here in my editor. So while I'm typing, those changes are being transferred to the service. The service is doing some stuff, sending me back, let's say, messages about these errors and warnings, and the editor is able to say, oh, errors and warnings, that's interesting. I will show them to you.
I think sorry, just to interrupt quickly,
Sure.
the speed point is really interesting. Like when we first started working on cloud-based editors, a lot of people said, no, they'll never be fast enough if they have to go to the server to give you that interactive experience you've come to expect from your local tools. But this thing, if you type an error, that error is appearing as fast as it is in Eclipse, even though it has to send the change to some service in the cloud, which is computing those changes and sending back a description of the problem. So there's actually a couple of synchronizations that are going on there to make that happen, and it happens, it's at least proof that it can be as fast as you get in a local environment.
So you can think of this as not only being, let's say, Dropbox for code, it's also a little bit like Google Docs for your code, right? Because it does this kind of the live syncing stuff. In addition to that, our headless JDT service does a little bit more for us. For example, it does content assist, real Java content assist. So nothing that is fake, nothing that is kind of inferred from this file that I have in my browser and guessing a little bit around, like some people do with JavaScript. What could be meant here, it's real, the JDT that's running inside the cloud, giving me back content assist. So I can do the real Java content assist here. So if I do this, type content assist, bang, it's there, right? Real good Java content assist for your Java stuff inside the cloud. The same stuff, and I could explore more and more, let's say, editor features here. One thing that we also implemented is navigation, so I can jump to this declaration of date. I jump to date, right, and then I'm there. Same stuff could be with renaming file, which is partly implemented, and this is what we got. An interesting effect of this architecture that is behind Flux is I would quickly like to, I see that this class implements an interface, so I open up another browser tab for this interface, which is my interface, and I change this. And I do not use any Java 8 stuff here, so my implementation will be broken. Right? I save this file. When I go back, without doing anything, right, the error already appears there. Because the headless JDT service that's running inside the cloud is not only able to say, oh, you changed this file, let me look at it and give you errors and warnings. It'll say, oh, it belongs to this project. Oh, the change to this file affects something else, produces 5 more errors in your project in the other file. So the editor is able to show the other error as well. Usually, in this case, I would do, what would I do? I would do a quick fix, right, at the implementation. Unfortunately, something we are working on, quick fix is close to be ready, but not ready to be shown. But I have my desktop IDE, and my desktop IDE in this case is still more capable of doing all that stuff. So let me go back to my desktop IDE. I go back to my desktop IDE, and I see, oh, it's synced, as I said. Right? Stuff is synced all the time with my desktop IDE, with my local computer. So if I open up home controller in this case, it shows the same error because my interface changed. And the interesting thing that I'm trying to do now is I will try to apply the quick fix here in my desktop. So I have the same file open, and I will do the quick fix here at the implementation. And you might have seen this. The implementation is showing up in the browser window as well, because it keeps sync of the same state, right? It starts to feel no longer than, oh, I'm working on my local machine, or, oh, I'm working over there in the cloud, and that's totally separate from each other. It feels like you're working in the same space, right? You're working on the same stuff. Under the hood, it's being synced, but it starts to feel like you're working on the same stuff, which is not meant to be you have a team of 10 people and you now start to work on the same stuff with 10 people, right? That's not the purpose of this. The purpose is you have your stuff synced to the cloud and you can change things. Stuff is here as well, so to really prove that it's really what I said, I go here and delete that. It's being deleted in my desktop IDE as well, right? And even the save state, so if I save my file here, save state is here as well, right? So it keeps stuff in sync. And the idea behind that, as John said, is you can now gradually move over to the cloud. You can start to explore this cloudy IDE world, even for Java projects, and we can improve that over time, adding more and more features for Java, adding more features for other languages. And maybe you wake up one day and say, oh wow, I haven't used my desktop IDE for a few days. Not for a few days. I only worked on the cloud because that was great. Or, oh, I was traveling, I used the browser only because I had a different machine with me. And then if you go back, oh, you go back to your desktop IDE and continue working with it. So that's the kind of the idea and architecture ideas behind that, which are I think very flexible. But we will talk a little bit more about the architecture in a minute. The other thing that I would like to show you is that I said I started from my desktop IDE and I synced my project. So that's the way projects come and go. But that's of course not, that should be not the only way. So we implemented a different application. That's a totally different application. It's a web application running somewhere. In this case, it's also running on Cloud Foundry, but that's just a detail. And this is an initializer application, something like a HTML5 initializer, but for Spring apps. Spring, it's just a demo in this case. And this app, that's available, it's running on Spring IO, and lets me create a Spring Boot application, right? I type in some details here, and then it creates a POM file or a Gradle build file or whatever, some skeleton thing. I can download it, import it into my IDE, or store it on my machine or whatever, usually. In this case, it can do a little bit more, as you might already guess. So let me say that's my ECE Martin demo. And I would like to select the web. That's kind of the flavors for Spring Boot project, but that's not the topic here. It should be a Maven project using Java 7. And in addition to generate the project and downloading the POM file in this case, I can already directly open that up in Flux, because it doesn't really make sense for me in this case to say, oh, I go back to my desktop IDE, I import that, and then I sync it back to the cloud. It feels totally naturally to directly start to edit this inside the browser window without leaving the browser IDE in this case. So I have the ECE project here, so I can start doing something within here. So the application stuff is already open. Let me see, there's already the Java service running behind the scenes. That is great. Let me quickly enhance this. Oops. I would like to implement a controller in this case. As you know, it's not yet exactly, gives you not exactly the same feeling as your desktop IDE. I don't know when you last time typed package and put the package statement into a new file. For me, it's 5 million years ago. But let me quickly implement that class. And this should do some simple hello stuff on the web. Nothing really fancy. So return hello from ECE Flux. Okay, that's great. To enable this as a Spring Spring Web thing, I need to put some annotations in there, and I think it's called request mapping. Let me try some content assist here. Content assist is not yet working. Now, sometimes it's not exactly working because sometimes it screws up the project definition. Interestingly, that's kind of a bug that's here. So I quickly change that. I fake it a little bit. So let me quickly fake this. Okay. Kind of a project setup sometimes gets a little bit confused. So I changed my project definition. Let me go back to my controller and see what's going on here now. Request mapping, that's great. So this one, and response body. You see that the content assist here for Java is able to insert the import statement already for me. Let me put in the controller thing. Okay, I'm done. That's enough for me. So the basic stuff is already working quite nicely, except for my little bug that I showed you, that I demoed. So that you do not think this is production-ready code. You go home and say, oh, I use it in production tomorrow. It's not there yet. Right. So I can work with my Java project here, and of course I would like to deploy it somewhere. So there's another Java application that we implemented, which is a deployer application, and this starts to show you that this Flux architecture, these kind of syncing protocol behind the scenes, is totally decoupled from each other, because the deployer app doesn't know anything about the editor. The editor doesn't know anything about Java. The Java tooling doesn't know anything about, oh, this gets deployed somewhere, or there is an initializer application that is being used. Those are all independent parts that are communicating with each other. So let me try to deploy stuff here. It's called ECE Martin. I push that to Cloud Foundry. Let's see if that works. And that might take a while, since Cloud Foundry is not really the fastest environment for deploying a totally fresh application. But I hope at least that it will start. So it shows me the live log output of the deployment process here. And, oh yes, we have to wait now. But before we wait so long, I will go back and talk a little bit about the architecture behind this demo. So what is going on behind the scenes? And I said that it's kind of a decoupled thing. So at the moment, everything is based on async messages. So there's no REST API in place, even though REST APIs might be the most important thing, or the most hyped thing at the moment, or the most established way to do web applications. There's no REST API at the moment, so we only have async messages. And in the first demo that I showed you with the desktop IDE, and I connect my project, and that's being synced to the cloud, there's a backup repository running in the cloud, and my desktop IDE is now communicating with my backup repository via those messages. So my desktop IDE sends out messages about what's inside my project, when a file is changed, when a file is stored, things like that. File is created, file is deleted. Those kind of events are being sent out by my desktop IDE for this local project that I connected. On the other side, on the other end of the message bus of the message system, sits the cloud repository and says, oh, I'm interested in those messages, so I keep listening to those messages, and I keep a copy of that project in a cloud storage somewhere. So there is some, on top of these messages, there is some kind of, let's say, a protocol implemented for doing this file sync, right? Files are changed, files stored, what is inside a project, things like that. And those messages are being sent around over this message bus to more or less everybody who's interested. Then I started to use the browser-based UI, the Orion UI, to access that. And the browser maybe has some kind of local storage to keep a copy, and it's also communicating with messages with Flux. So it communicates with these file sync messages to say, oh, I have to edit this file, give me this file, or what's inside the project, and things like that. And it doesn't know who is going to be answering that message, who's going to send an answer back. In this case, it could be my desktop IDE that is still connected. It also could be the cloud backup repository sending back the answer saying, hey, I know the content of the project, here it is. Or I can give you the file. Which I think is quite interesting. And then I said that, okay, we have something like a headless service that is running inside the cloud, some kind of Java service. And this Java service has to operate on those files. The Java service needs to know what's inside the project. How does the project look like? What other files are in there? How's the project defined? And can do that by listening to those file sync messages as well. So the headless Java service is also just connected with messages to the system, listening to those file syncing messages, and keeping a local copy of the project locally inside whatever the JDT service needs. In this case, it's kind of a local workspace thing. And in addition to that, it is also interested in, oh, you're typing. So I do not only listen to these file sync messages, I listen to the live edit messages as well. And whenever someone starts typing, I create this kind of working copy, or maybe it's already detailed inside JDT, right? It creates something where it can keep track of these typing changes and can do these reconciling and content assist stuff on top of. But that is already an implementation detail of the Java service. The editor doesn't know anything about that. The cloud backup repository doesn't know anything about that. It's just the Java service that puts the project into kind of a local shape and maybe some kind of memory representation of a Java model and whatever JDT needs to do that. An interesting side effect of this is if there's a new Java version coming along, Java 9, early snapshots of Java 9, right? And maybe, oh, the Eclipse JDT doesn't support Java 9 yet, or I would like to do something else with it. I could implement a different Java headless service that is using Java C, for example. And it's maybe not able to do content assist and all the fancy stuff like JDT, but maybe it's able to do some kind of the basic, oh, it gives me errors and warnings while I'm typing, or when I press save, it tells me, oh, this is not correct Java 9. Because there's a different service that's implemented in a totally different way. And again, the editor doesn't know anything about that, because the editor doesn't call the Java service, say, oh, please do reconciling for me. The editor component inside my browser sends out, I have typed in my file XYZ. And another service say, oh, okay, someone typed, I keep my local copy updated. And do something with it, or do nothing. The JDT might say, that's a Java 9 project. I don't know. I don't touch it. I don't even copy that stuff locally. The Java 9 Java service might say, oh, I copy that stuff locally because that's a Java 9 project. That's something for me. And that opens up different possibilities, because I can now start supporting different languages, not by changing the editor component or the UI part, but by more or less just implementing those headless cloud services. So there could be, as I said, there's one Java service saying, oh, I'm able to do Java 9, and one is, I can do everything up to Java 8. There could be another service saying, oh, I know how to work with Scala. I can give you content assist and navigation and refactoring stuff for Scala because I know how to work with Scala. Or I know how to work with JavaScript or whatever. Interesting possibilities, I think. Another interesting side effect of this is, and you might seen this, or you might already guessed it, that the backup repository inside the cloud is also just a participant in this system. It's not directly called by someone to do something. It is listening to messages and reacting to those messages, and sending back answers, or sending out a message when something's changed, and things like that. So there could be just a second, a third, a fourth backup repository being deployed to the cloud, and every backup repository could say, oh, I sync all projects that start with A, and I sync all projects that start with B, or I sync all projects that are being accessed in the last 20 days, because it listens to those edit events as well. So those backup repositories, they could decide on themselves what to do. So this produces a very extremely highly decoupled system, which I think is very interesting. I don't know if that solves all the problems, and whenever I think about that, there are more questions than answers coming along, usually, because I'm also kind of a newbie in these kind of, oh wow, this is all async, this is all message-based, this is all reactive, that feels strange, I'm used to my Java stuff. But it's really interesting. The more I think about that, the more ideas are coming up about what could be done with it. Some things are getting more complicated, some things are getting really, really easy and really interesting, I think. And when you think about the cloud and think, oh, I would like to execute some stuff, and I work on my RCP project or whatever, and I would like to execute something locally on my machine, you usually cannot do that with a cloud IDE. In this case, there could be something running on your machine, which is what we call an executor service. So it's just a service connected to the messages. It also keeps track of changes and kicks off a process when you try to start the application running on your local machine. So it kicks off running the app on your local machine. And I'm sure there are 5 million problems coming up when you really try to do that and really try to implement that, because I haven't really implemented it yet. But it is inside the space of ideas that could be possible and could be interesting to figure out what might be worth exploring, what might be possible using this way of connecting the worlds, connecting cloud IDEs, connecting desktop IDEs, connecting maybe even different desktop IDEs and different cloud IDEs together. And if I continue with my, oh, I have a dream, and I have a vision, and I can think of crazy things. I can think about the browser editor, the local editors and IDEs, clouds where different language services are being implemented for Scala, maybe a service implemented for collaboration, right? Something like, hey, you're working on this class, take care, your colleague is working on the interface, so maybe you should chat. Something like keeping aware of what's going on inside your project, or something like, hey, you're working on this class, if you're changing this method and you already changed it here, you haven't saved it, but you're changing this method, keep in mind that these 5,000 other classes inside these 10 projects in your company are being affected by this change. Take care. It could be done by a service running inside the cloud. It's doing some kind of analysis while I'm typing in the background, because of course the cloud has infinite resources, can do everything. It could keep track of projects that are stored inside your company, so not only by you, but maybe shared by others, and say, oh, I let you know when something dangerous is going on, which could be really interesting. Connecting things to GitHub, having more cross-references across projects and things like that, really interesting. They're not in your local workspace, but maybe in your local company, or on GitHub in general, or I don't know. Maybe indexing GitHub might be a challenge, but who knows?
So one of the things that I really like about this architecture is, if you go back to what I was talking about at the beginning, where we built our tools with this assumption of one CPU, one user, one display, and the tools we built, the architecture of the tools are perfectly suited to that. They work very well in that environment, but they're monolithic, they're static, they assume a single user. That architecture does not translate very well to the web. And we've tried that, and others have tried a similar approach. When you try to take tools designed for that desktop environment and try to just move them wholesale to the web, the architecture doesn't fit. And what I really love about this vision is not only does it let us move gradually to the web, but when we get there, I believe that's the architecture we're going to need. We're going to need an architecture that's dynamic. Services can come and go. They can be located together or not. You don't care where the files are, who's backing up your files. It's a very dynamic environment. It's a very scalable environment both up and down. It's really the architecture that you need when your tools are living in the cloud. So to me, that's really cool that not only does this architecture help us get there, once we get there, it'll be a perfect fit. Did your deploy finish?
Yeah. I just quickly went back to see what my deployment did in the background while I was ranting about the architecture, and the log output seems like everything got deployed, right? So the build pack on Cloud Foundry did the Maven build, the Spring Boot app got deployed, and it might be running. So let me take a look. Hello from ECE Flux. So that's already, the application is running on Cloud Foundry, which is great. That's what I tried. And the interesting thing, as John said, is that this deployer app is something, again, totally decoupled, right? Totally separate. And I can work on this deployment app saying, it deploys stuff every time you save a file, every time you press a button, every time you're typing. Maybe that's a bit too harsh for Cloud Foundry, but I don't know. Or maybe it's triggering your unit tests all the time while you're typing and saying, hey, the stuff that you're typing here is breaking the unit tests. Take care. Oh, now they are green. Stop typing. Don't know. Cool. Okay. So let's go back here. At the moment, we are exploring things, right? We are building these prototypes, and we are trying to figure out what does work, what doesn't work. So it's not production-ready code, right? I already said that. Do not use that in production tomorrow inside your company and come back and blame us if something does not work. As you've seen, bits and pieces are still a bit flaky. But we are trying to explore more and improving that over time.
But because it's so early, it's actually a perfect time to join in. So if you think this is cool stuff, definitely come talk to us, send us an email, get in touch with us afterwards. We'd love to talk to you about it, about what use cases do you have, do you have an interest in this kind of architecture, this kind of, the syncing service, definitely come talk to us and get involved.
Yeah, and since the beginning of this week, we even have a website for the project. Wow. Eclipse.org/flux. And a wiki development call, stuff like that. So if you're interested, please join us. Join the discussion. Implement your own headless services for the cloud. Interestingly, those services, that's maybe also an interesting detail. Maybe I haven't mentioned that before. Since everything is so highly decoupled, those services, they do not have to even run in the same data center, right? One service could run in this Amazon data center. Another service could run in a totally different one. They're just communicating. Maybe for some of those services it makes sense of a really high bandwidth network connection with low latency maybe you should put them together. For others, maybe not. Or there can be multiple running in multiple data centers, and the quickest one wins. I think we have still a bit time, so we would be happy to answer questions. I think there was a first one then here. Yeah. So the question is, I try to repeat the question so that everybody hears that. The question is it possible to have multiple Java services and using multiple instances of that depending on load or things like that? The Java service at the moment is interesting, and I think it's slightly special case because it's using JDT, and JDT is designed for single user. So at the moment, there is something like there are actually two services running. One service is trying to keep track of JDT services and firing up new JDT services for every user. So if you're starting typing, it fires up a JDT service for you, putting your project into that JDT service. If I start typing, it fires up another JDT service for me when my projects are sit in. So there can be as many users are concurrently working on the system, as many JDT or Java services are running on the cloud, which is kind of an implementation detail that was a result of the design of JDT, and that we decided to say we tried to not fake something inside JDT or hack around it, we use JDT as it is, and have one process, one service per user. It could be totally different for another Java service. In this case, the service is explicitly listening to events from this one user and only reacting to events from this one user. But if I slightly modify this controlling service in front of that, I can say, oh, there are always 3 instances running for John. So if one goes away or is crashed, the other one takes over all the time, or is doing the same stuff all the time again. You only have to take care that if you type contenances and 3 services are giving you contenances back, that you do not show the contenances 3 times, or things like that, or 3 times the errors. But that's doable.
Well, there's lots of established techniques for this in the cloud, right? You could stick the service behind a load balancer with several implementations in a pool behind it in a totally transparent way, right? So I don't think the architecture of Flux, specifically accommodates that today, but I can certainly see how you could do that, very easily with sort of standard cloud scaling techniques.
What I found out when I was starting to think about that is that what you mentioned, these, let's say, the traditional cloud techniques, like, oh, you put a load balancer and every more load you spin up more stuff. It's interesting how that behaves in this kind of async world, where a service decides more or less on its own what it would like to do tomorrow. That's an interesting combination, and I think it's spinning up additional questions, additional possibilities maybe.
Sure, yeah, I mean, to imply scaling is trivial. I mean, it's a whole problem area of its own, but I can certainly imagine how we do that. We haven't done it today.
Another question.
For the messaging, are you using any existing implementations like the popular MQTT?
Okay, the question is, what do we use for messaging? And that's really interesting, because every time I show this demo to random people, I usually get a recommendation back about which messaging technology I should use. And as far as I know, every message technology that is available on the planet was already included in that set. So I don't know what is the best.
But which one are you using?
Yeah, I just want to say before, it doesn't matter what I use. It definitely was not a choice of, oh, we take a look at 5 different messaging technologies and we choose one explicitly. At the moment, it's using RabbitMQ behind the scenes and WebSockets. But under the hood, the whole story is about exchanging JSON messages, JSON objects, JSON messages. That's the body of the message, and that's all we need, plus some security about if you're working on the system, I do not see your messages, right? You're seeing your stuff, I'm seeing my stuff, and the Java service is seeing your stuff and my stuff, things like that. But at the moment, the current implementation is more these kind of, the poor man choice of what can I use to get things up and running quickly. And that's RabbitMQ behind the scenes, and for the WebSocket stuff, we use Socket.io with the Java connection. But it's RabbitMQ looks nice, Socket.io looks a bit flaky at the moment. But yeah, don't know. But MQTT might be another. And I think in Orion you're using, or you start using it.
Yes, in Orion we started using MQTT for server-to-server synchronization, and it really has all the properties you want, right? It has, you can do delivery guarantees if you want, depending on what kind of message you're sending. It's supported by a lot of different middleware applications, including RabbitMQ runs MQTT. So it's definitely a good candidate.
Yeah, and maybe that will be the protocol of choice running on top of RabbitMQ and WebSockets in the future, could be. Yeah.
My impression from what you said was that the Eclipse IDE or the local IDE is a bit second class citizen. So you had all these Java services which showed prettily in the browser, but the IDE already has the information, but it is not being exchanged. Is there a way that the Java IDE gets the service messages as well and can send?
Yeah. Oh, a very good question. The question is, you got the impression that, to me, the desktop IDE is kind of a second-class citizen and just sit there and syncing files and does nothing and cannot benefit from this at all and cannot really participate in it, which is not the case, because from the Flux perspective, the desktop IDE is just one participant among many. And what the desktop IDE would like to do is a decision of, let's say, the plugin that we implemented for Eclipse, which could do everything. At the beginning, for example, the Java service that's running on Cloud Foundry at the moment, the first iterations, the Java service was running inside the Eclipse IDE and was acting as the Java service inside the Eclipse IDE. So the only thing was only working if I have my Eclipse IDE running somewhere in the world, doing exactly these kind of content assist, errors, and warnings for me, because the Java service was running as a component inside the Eclipse IDE. And in the future, there could be other, like what I said, these collaboration service or whatever, running inside the cloud, and the plugin for Eclipse could, of course, listen to those messages and engage in this cloudy environment as well, and benefit from that. Yeah, of course, definitely would be great. To me, it's not like replacing one or the other. It's more bringing those worlds together and making it, to me, it feels like making it one space, right? And you choose the right tool at the right time, and making it easy for you to choose the right and the best tool. And if someone says, oh, I'm interested in bringing back this awesome search stuff from the cloud into my desktop IDE, awesome. Would be great. Totally.
Yep.
Oh, I think there was another question, then I come back here, yeah? Mm-hmm. Yeah, there's a question about working offline and conflict resolution. In the case I'm working offline, right? Or maybe conflict resolution might be also a topic if I'm not offline. But yeah. The offline question is indeed interesting, and there is at the moment, we do not think about a very specific support for doing everything offline. There is certainly the option to say, oh, I have parts of this running on my local machine and continue to use my browser IDE or my browser UI, doing accessing the files and doing stuff with it. That could be possible. My other answer to that is always a little bit like, the stuff is still on your local machine. So if you're offline, you can still access it. You can still use your existing tools to work on that, right? So that will be possible. I'm not sure if it's worth to enhance the Flux experience with some kind of, oh, you have more or less the cloud on your machine and everything's running on your local machine. I'm not sure about that. Yeah, and the conflict resolution is there. At the moment of the file syncing stuff is not really an advanced implementation, so it cannot really, it keeps track of those conflicts, but it is kind of the latest guy wins. But we are planning to do a little bit more in that space, which at the moment feels like it will be based on the technology or on the mechanisms that Google Docs is using behind the scenes for conflict resolution on operational transforms, which can be used for this live edit syncing stuff, and that should also be enabled in Flux. Like, oh, I said it's just my project, right? And I sync my project, you are syncing your project, and if it's the same project, it could be, but it doesn't, I don't care. But of course, I could send you my URL. I can invite you to my session, right? You can open up a browser looking at my stuff, and we can work on the same file simultaneously, like exactly in Google Docs. And therefore, the Google Docs technology, which is called operational transforms, can be used under the hood. And with the technology or with the ideas and architecture behind operational transforms, you could also do these kind of keeping track of file changes. But there will be, I think, no explicit support for, or I have changed this file 5 times over here, and I've changed the same file 10 times over here, and then some magic happens and everything comes back together. You can try to do a lot of stuff there, but in the end, since I believe this whole thinking with the cloud is for you, or is for me, or is for John, so the case that I'm editing the same file over here, and I am editing the same file over there, and I'm editing the same file over there, and everything is disconnected, and then I try to bring everything together, should be a rare case. Right? And you could try to do as much as possible to resolve that, but I tend to not go that far to try to be totally awesome about this. To me, it feels a special case for the Flux scenario. And under the hood, I think you will always use Git anyway. Like, it's not replacing version control. Right? Under the hood, you still commit to Git or whatever your project, and that is, let's say, the last resort to kind of merge different changes, which will always, I think, always be a good last resort. That was another question?
Similar question. You always mention that it's a one-user solution. So one use case that comes to my mind that's pretty well supported by technology, I assume, is pairing, distributed pairing. So is there a technical limitation?
Yeah. The question is whether these kind of collaboration for editing the same file simultaneously with multiple people, or reusing the same environment with multiple people simultaneously, whether that is supported or limited or not. It's currently not explicitly implemented in a way that I could say, I invite you and give you, let's say, the access control, say you are allowed to view or edit my stuff. But technically under the hood, it's of course possible, and it should definitely be in there someday. Of course, yeah, because it totally makes sense. Yeah, and most of the stuff is in place. It's more the security that's at the moment very limited to. If you're authenticating with GitHub with the system, you're seeing your stuff, and if I'm authenticating with GitHub, I'm seeing my stuff, right? And there's no feature telling you, oh, you're allowed to see this as well.
I was even just wondering out loud about having a reconciliation service running in the cloud, right? Because if it's a really complex reconciliation algorithm, you don't want to necessarily push that out to all the different services. You want to be able to maybe aggregate that and have a service in the cloud that reconciles multiple users' edits and then sends back the combined results. Like, all kinds of things are possible.
I haven't thought too much about the different
We can design
results
it later.
of running mobile.
It's just an idea that
as I said, the more I think about that stuff, the more ideas are coming up, which is
Right.
great. I think there was another question?
I think Flux needs some technology to bring it not only to the web, but to bring the implementation that we have Eclipse and whatever service you prefer, bring it to whatever clients like IntelliJ or whatever you can think about. As far as I've seen from the code, currently the protocol, the JSON objects that you exchange are more or less the protocol that Orion uses for several servers. Will you put effort to define some kind of common protocol to communicate? So I've seen several talks at other conferences where people put effort in defining what's necessary to define things like compromises, formatting, syntax finalizing, whatever you can imagine, to make it something that you can use in several clients. Will you put effort in that, or is that not the use case?
No, absolutely. So the question was, will we define common protocols so that you can use these kind of services in different kinds of tool environments? So if you're using Eclipse or IntelliJ or NetBeans, can I use the same service across them? I think absolutely. Like I don't see why you have to be constrained to a particular tool or editor, right? The whole idea here is that it's decoupled, and if whether the endpoint is Eclipse or some other editor, or the service on the other end, is Eclipse technology or not, if you define the API of what those payloads look like, what the topics look like for those events, I see absolutely no reason why you couldn't integrate in any kind of tooling environment.
And at the moment, it's motivated by the clients that we have. Like, we have the Orion UI, we have the desktop JDT, so it kind of naturally looks a little bit like those guys. But as John said, it should be, the goal is definitely to say, in the end, it doesn't really matter if you have an Orion UI for that, or Eclipse J, or a totally different cloud IDE, or a totally different desktop editor, whatever. They should all be able to understand and deal with those questions. To me, it feels maybe hard to define that up front. So to come up front saying, I go back to the theater stage in a dark room, sitting there for half a year and then coming back with a perfect API. To me, so they should also evolve over time, and maybe we need to find out the more and more clients we build, what's the best API for that. But you have millions of years experience building APIs. I do not. So
Right, but for it to
Will be a
take off,
challenge.
the APIs would be extremely important, right? To be
Yeah.
able to build out all this whole ecosystem of services and tools and integrations. Those kind of APIs would be clearly important. It's just we're early enough that we want to evolve quickly and not have to worry about, being too rigid with those specifications right now.
And I think we also try to not put too much detail into the API and too much of a model of the world into the API, right?
Right, they're very lightweight events.
How does a project look like? A project always looks like this. This is a project, and there are files, and there's this definition, that definition, and a project can only have 5 source folders, and tests are included separately, whatever. I think we need to find a good balance between putting enough, let's say, building up enough information about the model, what the world looks like, so that different services are being able to work with it, and putting not too much into that, so that's too restrictive and too limited.
Especially, what makes it proposal? What is necessary to define highlighting? Is it the position, offset, length, color, whatever makes it color?
Yeah.
They overload colors.
Yeah.
Kind of mixture, so that is what I'm.
Yeah.
So I think we're out of time.
Okay.
But we don't want to keep you between you guys and beer. So please, if you're interested in learning more, come talk to us. Or the resources we showed. If you go to eclipse.org/flux, you'll see more information there. And thank you very much for attending.
Yeah. Thank you.